A model can be brilliant and still be the wrong worker. Put it behind a live support queue, let every decision take 30 seconds, and watch customers discover meditation. Gemini 3.6 Flash is interesting because Google is not selling it as the smartest model in every room. It is selling a workhorse, a model designed for the efficiency, latency, and reliability needed by agents at scale. That changes the scorecard. A chatbot can be judged one answer at a time. An agent may make dozens of model calls, tool calls, and verification steps before one task finishes. Small delays and token waste multiply across the loop. If a workflow needs 20 model turns, saving 1 second per turn removes 20 seconds. If 10,000 workflows run each day, that becomes more than 55 hours of waiting removed from the system. Speed is not a cosmetic feature. It changes which products are possible. Google says Gemini 3.6 Flash uses 17% fewer output tokens than 3.5 Flash on the Artificial Analysis Index, and reports reductions as high as 65% on one Deep's WE evaluation. While lowering the price per output token, those are launch claims, not universal laws. But the mechanism matters. An agent pays for unnecessary language twice. It pays in token cost, and it pays in time before the next action can begin. If the model can reach the same useful decision with a shorter trace, the entire loop moves faster. Consider a customer support agent handling a failed delivery. It reads the order, it checks shipment status, it compares policy, it drafts a remedy, it may request approval for a refund. Finally, it writes a response. The expensive design sends every raw tool result back into the model and asks for a paragraph after each step. The efficient design keeps the state compact. Order status becomes a few fields. Policy retrieval returns the exact relevant passage. Deterministic code calculates the refund ceiling. The model decides which remedy fits and explains it to the customer. Gemini 3.6 Flash belongs in the high-frequency decision points, not necessarily every point. Use a fast model for classification, routing, extraction, short planning, and routine tool selection. Escalate ambiguous disputes, risky actions, or difficult synthesis to a stronger model. The goal is not one model winning the company. The goal is a queue that keeps moving without lowering the correctness bar. Concurrency makes this even more important. Suppose a research agent must inspect 8 independent sources. A serial agent reads them one at a time. A parallel system can assign bounded searches concurrently, then ask one model to synthesize the results. Faster calls reduce the tail of that fan-out, but only if the branches are truly independent. Parallelizing dependent work creates fast confusion. If branch 2 needs the decision from branch 1, running both at once does not save time. It manufactures a contradiction and schedules a meeting to discuss it. Computer use adds another latency problem. Google integrated computer use capability into Gemini Flash so agents can see and act across browser, mobile, and desktop environments. A visual action loop includes a screenshot, model decision click or type event, page response, and another screenshot. Add 5 seconds of hesitation to every step and a 15-step form becomes painful. A fast visual model can make the interaction feel alive. It can also click the wrong button at high speed. That is why throughput must include failures. If one model completes 100 tasks per hour with 98 verified successes, it delivers 98 useful results. If another completes 150 tasks with only 70% success, it delivers 105 successes plus 45 problems. Whether that is better depends on the cost and risk of those problems. For a reversible product filter, retries may be cheap. For sending refunds, changing permissions, or publishing code, a 7-point success advantage can matter more than raw speed. Sensitive and irreversible actions should stop at an approval gate regardless of model latency. Google's own computer use guidance recommends defense in depth, confirmation for sensitive actions, prompt injection detection, sandboxing, human verification, and strict access controls. That advice becomes more important as agents get faster, not less. So how should you test Gemini 3.6 Flash? Build a representative task set. Include easy high-volume work, ambiguous edge cases, tool failures, malicious page content, and actions that must request approval. Measure successful tasks per hour, not tokens per second. Record total tokens, end-to-end latency, tool call errors, retries, approval accuracy, and the percentage of results that pass independent verification. Then compare 3 routes: Flash alone, a stronger model alone, and Flash with escalation. Do not average away the painful cases. Record median latency, but also the 95th percentile, the slowest 5% that users actually remember, separate model time from browser waiting, network calls, and your own serial orchestration. A faster model cannot repair a tool server that takes 8 seconds to return the same giant payload. Optimize the whole critical path, then check whether the model is still the bottleneck. The hybrid route often has the most interesting economics. Flash handles the ordinary path. A stronger model receives only the cases where confidence is low, evidence conflicts, or the consequence is expensive. This is why faster agents can beat smarter ones. Most production work is not a single impossible riddle. It is a river of medium-sized decisions constrained by time, money, and risk. The winning model is the one that keeps enough of that river moving while preserving the gates that stop disasters. Gemini 3.6 Flash should not be judged by asking whether it is the smartest model available. Judge whether it completes more verified work inside your latency and cost budget. Peak intelligence wins benchmark screenshots. Reliable throughput wins systems.